Right, grade 11s, this is a tutorial on how to convert a gradient into an actual angle. Right, so we know that the gradient is the change in y over the change in x. Now, where have you seen y over x before? Tan. So, tan theta is equal to y over x. So if those are the same, then it stands to reason that those are the same. So in grade 11, we may now use that m is equal to tan theta. This is also on your formula sheet. Right, now the important thing to remember is that the angle that you get from the gradient has to be in relation to a horizontal plane. So for example, if I use AC's gradient, it's not going to give me alpha. It'll give me this one over here, because that is in relation to a horizontal plane. But the horizontal plane, in this case, is going to be like that. In other words, in order for me to solve for alpha, I'm first going to have to get that angle, then work out the whole angle, and then simply say the whole angle minus the little one. Right, I've already worked out the gradients of each line, so AB, BC, and AC. And now I'm going to show you how to do this. Right, if I start with the gradient of AC, so that's from there to there, we can see that it's a shallow gradient, so a sixth is quite reasonable. Alright, so now I know that tan, let's just call it of x, is going to be equal to 1 over 6. I want to solve for x, so I'm going to just say shift tan of 1 over 6, and that's going to give me 9,46 degrees. Alright, then I'm going to use AB's gradient. That's going to be this gradient over here. And same story, I've worked out the gradient, so now I'm going to, for argument's sake, call it y. Right? The reason I'm not calling it theta, alpha, beta is because those are specific ones, so I can't use the same variable name if I'm working out a different angle. Right, same story, shift tan. $57.99. Right, now, like I said, this one's gradient now is for the full 57,99 in relation to a horizontal plane. So now I know that these angles are parallel because I've made them both horizontal, which means this 57,99 is from there all the way through to there. Right, so how am I going to get alpha? I'm going to take the big one minus the small one. And so I simply say that alpha is now equal to 57,99 minus 9,46. And there we go. Right, if I want to work out beta, same story. So here's beta. Now I'm going to take the gradients of AB, which I already have. Right? So, if I take the horizontal plane again, I know that this horizontal plane is parallel to this horizontal plane. So we can now see that an alternate angle is happening over here, which means this little piece is 9,46. Then I'm going to work out beta using the gradient, and that's of BC. There's BC. Right. Now I'm going to use tan of, let's call it Z, is now equal to 6 over 7. You'll notice that I did not use the negative. The negative is to determine quadrants, which we'll get to in a later stage. In fact, you've done the whole all sine cos tan thing, all the cos diagram. You've done it earlier. So I'm going to ignore the negative because all I want to do is create an angle out of this. So same story, shift tan, 6 over 7, 40,60. Right, that means this angle beta over here is 40,6 degrees, right? That's beta. Sorry, that's not beta. That's just that part. Which means beta is going to be this 40,6 and the 9,46 that I worked out earlier. Alright, just want you to have a look. If I did use the negative, and I said shift tan of negative 6 over 7, the answer is negative 40 degrees. The reason it's negative 40 is because it's going around the other way around the circle. So whenever we do shift trick, we ignore the negative, but we'll get into that at a later stage when we do general solutions. Right, then the last one to work out is theta. Now, we already have two angles, so there's no need to try and use gradients to work out theta. We're just going to use sum of interior angles of a triangle. So theta will equal 180 minus the sum of those other two angles. Alright, and that's how you use tan to convert gradients into angles.